Discussing John Schulman on the Robot Brains podcast by Peter Beal. Schulman is the creator of GPT-3. I think is instrumental in that whole endeavor of OpenAI. His background is he has an undergrad in Caltech and a PhD from Berkeley. Actually did it with Beal and then went into industry and works for OpenAI and was instrumental in developing the large language model underlying ChatGPT and obviously made a big splash. So he said something very interesting that I want to discuss today, and that is that large language models can help us do science differently. I think I've been thinking about this at least since XAI was founded. I've been thinking about this obviously even before, but the fundamental idea here is that we could have a different way of thinking by using AI, meaning different than humans. And there's another completely unrelated episode that I want to combine in this particular episode today. And what I mean, episode is a story that I came across. I'm in Santa Barbara right now, and I'm just doing some research on UC Santa Barbara for my son who might go here to study physics. So I came across Professor Matthew Fisher, who has written a very interesting paper, which is, are we quantum computers or just smart robots? Now, the gist of the paper, as far as I understand it, is simply, okay, are quantum operations happening in the brain? And if so, could they be the clue to consciousness? What I find interesting about this particular work is that we're looking at different things. Here's why. Everybody, I think, in neuroscience and even lay people think that the brain is governed by electronics. And that is could be true. It's probably wrong. And the reason we believe it's electronics is because the last 100 years actually were the age of electronics. It was the discovery of the electromagnetic effect or whatever by Einstein of 1905. The development of quantum physics, quantum mechanics, which is mainly focused on electrons. The evolution of electronics as an industry, and then of course electronics as underlying the computer revolution that we're still living in. So everything was about electronics, and humans in the history of science have always done this. They've discovered stuff in physics, and then they've applied the knowledge to everything else. So, for example, in the 19th century, hydraulics was a big deal, and we thought that the human is all just some sort of hydraulic pump that is governed by fluids. And when we had Newton and his Principia Mathematica, we thought that everything is some sort of equilibrium clockwork based on Newtonian mechanics. So we do that a lot. We come up with stuff which usually we observe nature, we see stuff, and then we develop a theory that works to apply to, let's say, the movement of planets in the case of Newton, in case of building machines, in case of hydraulics, in particularly steam engine, all that stuff. So then we apply it to everything else, in particular biology. And I think here's where I sort of combine those two trains of thought, which is we have John Schulman suggesting that the new forms of AI that we're developing with large language models could be also helping us develop new forms of science because we're looking at the world differently. And then Matthew Fisher's approach towards the brain, again, he's looking at different things. In this particular case, actually, he's looking at nuclear spins of atoms, in particular lithium atoms. I'm going to explain why lithium and all that. And then he's kind of concluding that there might be quantum operations in the brain, which is just an interesting new potential way to look at the world. And I'm just guessing here, this is not complete conjecture, that we could enter in the age of spintronics instead of electronics. Because the more I look at quantum physics and applications of quantum in problems that could be solved very closely, very, very immediately, those are all sort of related to spin, electron spin, nuclear spin. In other words, instead of using charge and voltage like we do in electronics, we use spin for different types of applications. This is not even wrong podcast. It's August 5th, 2023. This is Delco. Since the last update, we're down roughly 12%. The market is down 2%. For the year, we're up 118%. The market's up 18%. We're outperforming by 100%. Just before I go into the conversation, we had unfortunately some drawdown in the markets. There's quite a bit of action on the treasury side of things. The treasury is driven by a couple of things. I would say there's probably some fundamental reason why the treasuries are selling off, but I wouldn't be surprised if also we have a shake-up in the market. People are cash starved and therefore forced sell. It kind of feels like that. But let's just give a little bit of a background on the markets. We had quite a few weeks ago now, the Bank of Japan basically changing their monetary policy stance by widening the range of yields allowed on the yield curve. So their yield curve management, which they've been applying for decades now, is, it's kind of basically saying we're going to do a little bit higher rates. Now that is obviously, I would say, that is creating quite a bit of an earthquake in the financial markets. In other words, we have this situation now where a lot of people are sitting on the yen carry trade. They're short yen, long other stuff. And if you raise rates on them, even if it's only by 10, 20 basis points, that hurts. And I think that's what we're seeing right now. And we're seeing forced selling in treasuries because probably people were short yen, long treasuries. Things along those lines, hedge funds. We have Bill Ackman talking about treasuries. Usually people like Bill Ackman, they're, herd mentality type people. They follow, they don't have any fundamental or conceptual knowledge about what they do. They know, their business model is to know what smart people are doing and then following them and then, making them a name for themselves because they get to talk to people on Bloomberg and CNBC. So that's what's going on in the markets. We believe that it started with the yen creating havoc in the market, but we also have good macro data in the U.S., which is probably putting a bit more pressure on treasuries. So we have those two reasons, which we believe could create more havoc in the market. Probably some emerging market trouble, that kind of thing. We could have a sell-off in growth stocks, which could affect us. These are not things that we trade on. Let's be clear. We're not going to trade on these things. Our fundamental view of the world is still the same. We're long Tesla and NVIDIA for the electrification of the world and the AIification of the world. So we have those two factors still very, very, very much in place. But we have to embrace ourselves for some impact, and I think we could have that in the next couple of weeks until we have better fundamental data coming from the companies that will reverse that. Now let's talk about the actual story of this episode. So we have John Schulman, I think, creator of ChatGPT, instrumental research lead at OpenAI for those types of products. Certainly very knowledgeable about large language models. And on the Peter Abilo podcast, which was fine. It was a good podcast, maybe a little bit less substance than I would have thought, but that's not important. It doesn't really matter. What matters is he said a few interesting things that I want to convey here, and one of them is that we could do science differently. Now, I've spoken about this a few weeks ago, about doing science differently with AI within the context of the Knowledge Lab of the University of Chicago. They talked about just simply, psychological, political motives to have different approaches by AI because they're not, confined by status and tenure and all that. But I think Schulman talks more about real technical issue, fundamental differences. And the big one, the really important one is that we could represent something like biology, for example, right? In the same way we do, large language models, we could tokenize it. We could use electron spins, nuclear spins, things along those lines. We could use them and, do the same thing we're doing with large language models, self-attention, train the model, and then let the model think in its terms, not in human terms. This is the key. so far, the way we do AI is we use AI to help us think, which is fine. That's a tool, like a calculator is an AI that helps us think. A text, uh, you know, text, or let's say grammar correction AI or those things. They're all helping us think, us humans, right? Now, what I'm suggesting here, based on John Schulman's comments, is that why do we need the human in the loop? We can still formulate the problem. For example, help me understand consciousness. Go, train yourself based on a tokenized large, let's call it large token variable space model or large language model, let's call it LLM, and then come up with solutions that I haven't even thought about. This is the key. This is the beauty of this approach. Just, I don't, it's not important what I might know. It's not important what I might think. What matters is, can you give me interesting ideas, solutions for my problems? This is the key insight. And within that context, I want to mention Matthew Fisher's comments, which is completely unrelated in a sense, but it is related. And what Fisher is talking about is the following. He's talking about the idea that we could use nuclear spins to we could, well, let's just start with the basics. How about we start with nuclear spins and look at them, and then try to understand how they relate to brain function. Maybe that's an interesting approach, right? Nuclear spin, brain function. Now imagine if we could characterize a nuclear spin of, let's say, a lithium atom. In this case, okay, let me give you a little bit of the background. So Matthew Fisher is professor at the University of California at Santa Barbara. Physics is theoretical condensed matter physics. So he's not an experimentalist, but he thinks of what happens when you condense stuff. That's sort of that's his profession, right? And he says in the paper, Are We Quantum Computers or Just Smart Robots? That, he was depressed and this and that. And he used lithium as a tool, as a drug, right? Lithium is known to be effective in people with mental issues. And he used it and helped them. But then he started noticing that different isotopes of lithium have different effects on people. In other words, you use an atom with the same amount of electrons, but a different amount of stuff in the nucleus. The difference between lithium 6 and 7 is that lithium 7 has 4 neutrons and 3 protons, and lithium 6 has 3 neutrons and 3 protons. So there is the same amount of electrons, the same amount of protons, but 1 more neutron. And lithium 6 and 7 have different effects on mental capacity of rats. They've been doing research on rats. So the conclusion then is, well, that means that there's something going on in the nucleus. It's not the electrons. And I think this is the key here. Why are we always looking at electrons? Maybe it's not about electrons. Maybe it's about nuclear spin. Maybe it's about spin in general, and then maybe it's nuclear versus electron, because the difference between Li6 and Li7 is it is the nuclear spin. It's not the electron. Now, maybe the electron also has different effects that we don't even know about because of the neutron. So clearly the neutron probably is not that neutral. It's neutral as far as charge is concerned, but if we only look at charge, then yeah, it's neutral. But if we look at spin, it's not neutral, so on and so forth. I find that fascinating because it just shows you that we humans, we get stuck with thoughts, we get stuck with, bias, overconfidence. All of these things are, they're overwhelming us because we have knowledge that works in electronics, and then we apply it to other things. So back to John Schulman, and now let's synthesize Matthew Fisher and John Schulman. Well, John Schulman is saying, let's use a self-attention model for science and come up with new ideas. And what Matthew Fisher is saying, let's look at different things. Let's look at nuclear spin. And we might actually get some really interesting results. So I think these are two beautiful examples of how AI can help science. So to summarize, what I'm trying to say here is that instead of trying to develop large language models to help us think the way we think now, maybe the models can do the next step. It's kind of a bit like when wireless came to third world countries, right? They didn't have to build the fixed line, and then they went to wireless straight, and the kids in countries like, Africa or whatever, in places like that, are as savvy, if not savvier, let's say, with online payment or mobile payment, because they don't even have all the stuff that we have. So the same way we could frog leap or leapfrog science by overcoming all the human biases, not just political and social, but also fundamental knowledge and think the way we think. Why be stuck with electronics? Let's go one step further. This is the beauty of this combination of John Schulman's appearance on the Peter Real podcast and Matthew Fisher's research on the effect of lithium on mental cognition within humans. And by the way, I think what Matthew Fisher is onto here is really not just a drug for mental issues. It is really, I think it's a path towards understanding consciousness. He says that in his paper. Consciousness is a physical phenomenon, which goes back to David Deutsch, that every computation is physical, consciousness is computation, and we have a shot at understanding consciousness better if we start looking at different places and use large language models to combine them into knowledge that could solve problems and help us humans solve problems.